Hey guys, welcome to a new video on the Cell Doctor channel. In this video I'm going to open this Luna 2000 battery and see what's inside. At the first sight I noticed that this is not a regular battery that it's used on solar panels, and I will tell you in a second why is that. Here on the right side you can see the battery bank, but here you have another component that's called a DC to DC. If you're checking the spec of this battery, you will see that 5 kilowatt hour battery in capacity. The input is between 350 to 4035 volts and 7.5 amps at 2.5 kilowatts input and output. The input and output is 350 to 435 volts at 7.5 amps, so it will give a total power of 2.5 kilowatt. Alright, so there was a lid on top of this. I took it off and I noticed a hard smell of lithium, and that's not very good, to be honest, because this means some of the cells vented. But I want to disconnect everything and take a look what's inside. It has some side screws and I believe this should come up. I just got this battery yesterday and I'm very curious to see what's inside and if we can actually make something to connect to the Huawei inverter, because that's a popular inverter, and now I can see why those don't break that much, because the DC-DC it's handled by this battery, and it also has another DC to DC boost that I think we're going to have a look into it as well. Alright, so the side screws are off. Let's see if this lifts up. If this lifts up. Alright, so I took out the brackets that was holding these inside. They have a groove inside and it was not possible to just lift it. It has this margin right here, and as long as that keeps it straight, you cannot just lift it. You need to get those brackets out as well. Alright, so I want to see if I can take off this lid, this plastic lid. Because I want to disconnect the Alright, so it's it has some small plastic clips on the side. Alright, so this side is up. It also has some double-sided tape. Let's see if this will help. I need something that will not short circuit the cells and help me push. It looks like this is doing the job. Yeah, it has some silicone. It also has the temp sensors glued and also the balancing leads, so must be very careful taking this apart to not break those. So it took apart, but there's two temp sensors that got glued to this. Alright, so this is how the top of the battery with the lid off looks like. I see it has multiple temperature sensors. See, 1, 2, 3. Oh, it actually has 8 temperature sensors. T7. I can see that the date on this battery is 2020. Yeah, so it has like 3 years. It's month 10, 24. It says that it's a 100 amp hour battery with a nominal voltage of 51.2 volts. Rechargeable lithium ion battery. So it's using lithium ion cells. I see that it's using some big cells, but it's hard to tell which kind of cells because everything is encapsulated in there. Let's measure some voltages and see if all the cells are balanced. Let's see if you can see this one easier right here. So this one is the positive side. Let's see the entire voltage now. So this is the positive. The voltage is 52.5 volts. And let's go backwards. 3.2, 3.2. It says lithium ion on the cells, but to me this looks like it's lithium phosphate. The good thing is that all the cells are balanced. It can be lithium ion, but the voltage seems a bit too low for that. But there's no way to tell without taking this apart, and I honestly don't want to take this all the way apart. Alright, so there's actually a label that I can take a photo of, and that looks very similar to the lithium phosphate cells. Where is it? Right here. So it's it says that it's a 320 watt hour battery. So on the amp so on the power right here it says that it's 100 amps, and that means it's the nominal voltage is 3.2 volts on these cells. So they're using 320 watt hour, and that's 100 amp cells right there. Okay, so let's check again the temperature sensors. So it looks like it has 3 per row right here, and you have the other 3 right here, 4 actually with this one. So it's T8. Alright, so it starts here. It has 1 every 2 cells right here. So you have 1 here. These are the temperature probes for the leads. So these are the positive and negative, and then you have another 3 temperature sensors on the side right here. And then you have the balancing leads going. Yeah, so totally these are lithium phosphate cells. They are not lithium ion. And if you're using lithium phosphate cells with a nominal voltage of 3.2 volts, 3.2 multiplied by 16, you get 51.2. Yeah, so the capacity is right. It's 5 kilowatt hour battery. Okay. Next thing, I want to remove this one as well. Because really the reason I want to take this apart is to check the because the reason I wanted to take this apart is to check the DC to DC they're using for this battery. I want to add some tape on the terminals to avoid short circuiting the battery by mistake. So the way this battery works is it takes the 51 volts from the cells, goes into this, which has both rows of BMS and also DC to DC boost, and that gives you 400 volts at the output of the battery. That allows you to use thinner wires because the current is not that great. If you would have used only 50 volts and wanted to deliver 2.5 kilowatt, you will need thicker wires to do that. So I want to remove these connectors. At least I am glad that they did not lie about the capacity of the battery, because that will be bad. Okay, so it seems that I disconnected most of the wires. There are still the wires that go back here, but maybe I can reach those after I disconnect this module. Actually, I don't think that it's possible to remove this DC to DC without taking the battery out. These brackets right here are just for that, to lift this battery out of the case so I can reach the rest of the DC to DC part. So I'm going to look for some rope to tie this and attempt to lift it. Okay, so I found these in my car, and I will attempt to lift this. First I need to tie one end, get it through this. Alright, so let's see. Oh, that was easier than I thought it will be. And in this way we can actually take a look at the sides of the battery as well. Maybe we see something useful. So we can see that it has the blue cells right here, and it's also tied with a strap. So this kind of lithium phosphate cells, or the prismatic type, needs to be pressed together, because otherwise they will start deforming when you start pushing amps or discharging it. Alright, so not much to see. I got my workout for the back. I'll put this aside and dive into the DC to DC that interests me. Alright, now we ended up with this empty case, almost empty case right here. Wire management looks good, and you can see they use 2.5 millimeters wires for the high voltage. That's what looks like. Alright, so with the battery out of the way, it's time to see how I can actually take that board out of the case. To have a closer look on the components that's using, the BMS part and the high voltage part as well. So I think we can take this apart by removing some of these screws. Okay, so let's look for the screws that actually hold this in place. Alright, I think I saw them. Hooray! I found the screws that keep this in place. There's an earthing screw right here that needs to be removed as well. And I still have to remove this heatsink in order to get this out without removing those brackets. So let me get to that really quick. Alright, so it had thermal paste on the heatsink. That's why it was glued so hard. Let me try to remove this now. And voila! This is it. This is how the side looks. It has a rubber gasket all the way around. That's quite an interesting design, to be honest. It's very nicely made. Let's see if I can remove all the wires to take this apart. Yeah, so we have 2 wires to disconnect. Right, there's the high voltage plus, that's on top. Alright, so I can separate the box now. And let's have a close inspection of this. This is the heart of this battery, I should say. This is a very important part of this battery. This takes care of the charging, discharging, and also balancing of all the cells. So let's dive deeper.